Professor Deb here. This is a video lecture from Technical Mathematics on changing forms of a complex number. There are several videos in a series regarding the complex numbers. Let's take a look at changing the forms. Now, this presentation is a little bit different than most people do. Most people show you one form and then another form and then another form. I'm going to show you all three forms across, and we'll change from one to the other to the other. So I'm going to introduce all three at the same time, and hopefully it'll be a little bit more understandable and not so confusing that way. All right, at any time stop or pause the video to examine the material more thoroughly. Let's start with that rectangular format. Okay, the rectangular format is written as A plus BJ. Now remember that A is actually the x-axis or the real axis, and this axis is the J or the imaginary axis. Okay, if we're given theta and r, we can find A by saying r cosine theta. And we can find BJ by taking r sine j of theta. So let's give this a value and try it. Let's use 5. And that looks to be about a 45-degree angle to me. So let's find A. A equals 5 cosine 45 degrees. And if you put that in your calculator, you'll find out what A equals. And then B will be the same thing, equals 5 sine, and we want to make sure we keep that J symbol, of 45 degrees. So that will give you a value for A plus BJ. All right, let's take a look at polar. Now the polar format of a complex number has three ways of putting it. We're familiar here, we just talked about the A plus BJ. That's our rectangular format. And we remember that BJ was this distance, and this distance was A. All right, now given R again and theta, given A and BJ, we can find out what R is. So we're given a rectangular format right here, A plus BJ, and we're asked to convert that to polar format. So first of all, for polar format, we need R and theta. How do we find R? Why, that should look familiar. That's the Pythagorean theorem. So we take the square root of A squared plus B squared. And to find theta, we take the tangent of -1, or the inverse tangent, of the rise over the run, BJ over A. All right, let's give those values again. What did we give them? 5 and 45. And let's write out the different formats. Say what we found from this is 5, and what we found from this is 45 degrees. Okay, now these are the three formats to write polar designations of a complex number. So this one would read 5 cosine 45 degrees plus, don't forget that imaginary designation, sine of 45 degrees. Or we could write it simply 5 CIS, which stands for cosine imaginary sine 45 degrees. I kind of like this one because it's a little bit shorter and I'm a little bit lazy, so it's easier to write. Now this is another one. Now actually your computer doesn't have the correct signal, but it's a angle and theta, and this angle symbol I can't find in the computer system. So we'll rewrite this. I won't use this too often. 5 angle 45 degrees. So this is taking our a plus bj right there again, and we're converting it to polar format. We find that by finding the r and the theta. All right? Okay, one more form. This is exponential. Given r, given the polar format, what did we say that was? R CIS theta, that was the polar format, right? Okay, so what did we designate this as? We'll keep it the same, 45 degrees, and r as 5. All right, when we're working with exponential form, the theta is given in radians. So it's very similar to the polar format. However, we have to convert the degrees to radians. So let's see, 45 degrees should be pi over 4. I'm sorry, I don't remember what pi over 4 equals. But we will take the 45 degrees times pi over 180, and that will equal the value in radians. In some of the examples, I'll show you an actual conversion. I'm going to write that out, radians. So what we would have then is 5 e to the radian value of degrees j. All right, we'll get more specific in here, but essentially all we're doing is taking that theta right here, 45 degrees, and converting it to radians. And we do that with our conversion pi over 180. All right, you ready to do some conversions? Here we are. Here's our rectangular format, here's our polar format, and here's our exponential format. And I've given our little tips and keys in here for each one of them, and we're just going to go through and convert them. So this is what we're given right here. We're given rectangular format, 5 plus 5j. Now, the idea here is that we want to take this rectangular format and we want to convert it to polar format. How do we do that? We have r, so r will equal the square root of 5 squared plus 5j squared. First of all, let's get a better look. Hopefully you viewed the graphing video. So we've got 5, 1, 2, 3, 4, 5, and j. So that's going to be our point right there. Now what we're going to develop is r and theta. That's how we designate it in polar, to find r, after we run that through, we get that as 7.07. And theta would be that inverse tan of the rise, or the imaginary axis, over the real axis. And I think what you'll find is there's our 45 degrees again. Okay. That makes sense. If it's 5 this way and 5 this way, theta would be 45. So now we have to write it. Remember, there's 3 formats. So we'll write this, we'll pick out this format. You know I like that one the best. So the the polar format for 5 plus 5j, the polar format is written 7.07 CIS 45 degrees. All right? So there is our polar format. Now, how do we write that in the exponential format? Well, what did we say? We had to take theta, which is 45 degrees, and we had to convert that to radians. So 45 degrees times pi over 180. If you run that through, this is what I couldn't do in the slide before that. That equals 0.785. And I'm just going to write down here radians, just to remind us that that's not degrees, it's radians. All right, now how do we write it? We want this format. So we write, let's see, what was R? R was 707. And we use that E designation, and theta is 0.785J. All right? So here we have the same point, right here, same point. In rectangular format, it's called 5 plus 5J. In polar format, it's 7.07 CIS 45 degrees. In exponential format, the same point is 7.07 e raised to the 0.785J. All right, so again, my way of doing this, instead of just introducing you to several examples of rectangular format, I show you all 3 at the same time. And we're able to take a rectangular format, convert it to a polar format, and convert it to an exponential format. Want to try it again? Here's another example. We're going to do the same thing, only this time it's negative 9 plus 3j. Well, let's find that. I'm sorry. That is supposed to be yours. This is the one we're supposed to work on. We'll get to that slide in a minute. That's going to be your problem to work on. So here we go. Let's try this one. This is the one I want to do for you. So 8 on the real. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're going to go all the way out here, and we're going to go down negative 2 on the imaginary axis. So that's that point right there. Here's our vector, R. And actually, our theta will be this angle. All right, ready? Sure you are. Let's convert that to polar. So how do we find r? R equals the square root of 8 squared plus 2j squared. Now it doesn't matter whether this is negative or positive because it gets squared, right? Okay. And that should come out 8.24. So theta then is the inverse tan of the rise. Now this time it's very important to put that negative symbol in there, over 8. And what we'll find is that that equals negative 14.036 degrees. Now that's negative. Here's the negative. Remember, it's negative from 360. So in order to get the actual angle that we want, we subtract that from 360. And we get our actual angle of 345.9 degrees. All right, what do you say we write it in this long format this time instead of writing it in the shorthand? So we're ready for that, right? 8.24 cosine. I had to pick the biggest angle, right? We're going to call that 346. We're just going to round that. 346 degrees plus j of 346 degrees. All right? So that is our rectangular format again. I'm sorry. That is our polar format. Now we want to go into the exponential format. So we have r as 8.24, but what do we need to do? We need to convert that theta into radians. So here we are. We're going to take that 346 degrees times pi over 180. That's our conversion to get it to radians. And we're going to find that that's 6.038 radians. So we need to write it in the exponential format. R was 8.24. E to the 6.038j radians. And that is our exponential format. We've got the same point right here. This is how to name that point in rectangular format. This is how to name that point in polar format. And this is how to name that point in exponential format. All right, that one I mistakenly showed you before is yours to work out. I'll give you a little hint. We're going -9, that's over here, and 3j. So we're naming this point right here. Whoops, I didn't do that too well. All right, so stop the video and try this one yourself. -9 plus 3j. Take it over into the polar format, and then take it over into the exponential format. Check the solutions on the website. All right, you ready to go a different way? Now we're given polar format. So let's see. Let's describe where this is. 305, this is 360, 270. It's right about in there. And this equals 8. So we've got a point right there in the fourth quadrant. Okay. We're going to convert that to rectangular format. How do we find A? A equals R, which was 8, cosine of 305 degrees. And that should equal 4.59. Now to find B, we take 8, and it's the sine of 305 degrees. And that should equal a negative 6.55 J. So we're going to be a little fancier this time. And we're going to rewrite that rectangular format like that. 4.59 plus a negative, or you could have written minus 6.55 J. That is our rectangular format of this placement, of this point right here. So we've got our rectangular format. Now we're going to take that the other direction into our exponential format. First of all, what do we need to do? We need that degrees converted over to radians. So we're going to take 305 degrees. I'm going to multiply that by pi over 180 degrees. And we should get that as 5.32 J radians. So we rewrite that as this format. That's the exponential format. We have, let's add that little flare in again, okay? So we've got R, which was 8 e to the 5.32 J. And that is our exponential format. So we've taken the polar format of a point right here, and we've written it in rectangular form, and then we've written it in exponential form. Let's do one more example. And then I'll give you one on your own, right? So here is 2 CIS 115. We're going to take it into rectangular format. A is going to equal 2 times the cosine of 115 degrees. And that should equal negative 0.845. And B should equal 2 sine J of 115 degrees. and that should equal 1.81J. Let's take a look at that first. Let's see, where actually are we? We're at 2, positive 2, but we're all the way over here at 115 degrees. So we're right here, 2 at 115 degrees. Does that make sense? Sure it does. Look at A. A is a negative number. Sure it is. And B is a positive number. Yes. So it makes sense. We're right there. In rectangular format is negative point, oh, we forgot our flare, right? There we go. Negative 0.845 plus 1.81J. There's our rectangular format. And now we need to convert that to exponential format. We first have to take theta and convert it to radians. There's our conversion, pi over 180. And that should give us actually 2. So we rewrite that. Let's remember to get our flare. So we have R, which was 2, E, 2J. And there's our exponential format of that number. Doing good so far? I jumped real quick. Here we are. Here's the one for you to do. Here's our polar format. And you want to take that into the rectangular format. Use the sine and the cosine to find A and B. And then you want to take it into the exponential format, convert it to radians, and here is your R10. All right, stop the video and try that. All right, we have one more format. Exponential format. This is turning out to be lengthy because we have so many formats to go through. All right, we have R as 5. And we need theta, so we need to convert that 0.5 J times 180 degrees. We want to convert it to degrees this time, so we use the flip of the converter, and we end up with 28.65 degrees. So how we'll write that, let me go down a little bit, and I'm going to write it in the long format. 5 cosine, I'm going to go to 1 decimal place, 28.7 degrees, plus J sine 28.7 degrees. Well, I forgot our flare, didn't I? We want to take that over into rectangular format. How do we find A? A equals 5 cosine 28.7 degrees, which should give us 4.39, and BJ is equal to 5 of 28.7 degrees. So we rewrite that. Where's our flare? I'm not going to forget it this time. As 4.39 plus, oh, we didn't say what that is. I got to go back. I'm getting ahead of myself. 5 times the sine of 28 will equal 2.4j. Sorry. Okay, now let's go back. We're ready to write that. 4.39 plus 2.4j. So that's our rectangular format of 5e to the 0.5j. Now this is getting into a lengthy video, so we were going to do the same thing with 2.3. We'll take that and we'll convert it to theta. We'll convert the 4.2 using the pi over 180 into theta. And then we'll use the r cosine of theta, that would be 2.3 cosine of what theta is, and r sine of theta, and you would get the rectangular format. Look back at the previous slide if you're confused with that. But I'm going to hurry this up a little so that we don't get too lengthy. And I'm going to give you one to try. Here's 8 to the 1.9j. Take that 1.9j and convert it to the polar using the pi over 180. And then you'll find theta. And then find A. And then find B. And you'll be able to write the rectangular form. Stop the video. Try this. Take a look at the earlier one. And find the solutions. In the other part of the website. Thank you for listening. This is the end of this video.